Hi, this is Mrs. Shopper with Chapter 2, Section 8, Proving Angle Relationships, and this will be your last video for instructional video for Chapter 2, and I'm going to give you a heads up that there will be a lot of writing. There's a lot of postulates and theorems and information that you will be gathering in this video, so you will be needing to utilize the pause button as we go through. So just a heads up, that's what's going to be coming up as we go through these notes. Our goals are going to be writing proofs involving supplementary and complementary angles, and then to write proofs involving congruent and right angles. We're going to do just one proof in the video, and our in-class discussion is going to be walking through a couple different proofs just so we can have that dialogue in class about processing through proofs. And again, this is new in our thought process. We've been doing it for a few days, and so I think best we'll show you one in the instructional video, and then we'll take you through in class a few more proofs. Here we have the protractor postulate and the angle addition postulate. The protractor postulate just says that given any angle, the measure can be put on a one-to-one correspondence with a real number between 0 and 80, talking about, angle measurements. The angle addition postulate, please pay close attention to that. D is on the interior of angle ABC if and only if the measurement of ABD plus the measurement of DBC is equal to the measurement of ABC. Using that sketch in your notes will be helpful, and you will be utilizing the angle addition postulate a fair amount. So of these two, for sure, the angle addition postulate is going to be the one you want to focus on and make sure you know. Utilizing the angle addition postulate, just to show you here how that works, what we're saying is that assuming that this ray right here is in angle JKL, we know that the measurement of angle 1 plus the measurement of angle 2 is equal to the measurement of angle JKL. All right, so the measurement of angle 1 we don't know. The measurement of angle 2 is 58, and the measurement of JKL is 162 degrees. So therefore, we can determine that the measurement of angle 1 is 104 degrees, because the measurement of angle 1 plus the measurement of angle 2 is equal to the measurement of JKL. That's using the angle addition postulate. We have a couple theorems, the supplement theorem and the complement theorem, and it's naming something that you already know. If two angles form a linear pair, then they are supplementary angle, which means that their measurements equal 180 degrees. And then the complement theorem, if the non-common side of two adjacent angles form a right angle. So the non-common sides of these two angles are here and here. And if those two lines form a right angle, then we say that the angles are complementary, which means that their measurements equal 90 degrees. The properties of angle congruence. We have the reflexive property of congruence, symmetric property of congruence, and the transitive property of congruence. And this should be somewhat of a reminder, a review for you. You've seen these before, and they're now in regards to angle congruence. Please have those three also written into your notes as we go through. So the reflexive, symmetric, and transitive properties of congruence. All right, now this one's a little bit different. This is the congruent supplements theorem and the congruent complements theorem. And when you name these in a proof, you're welcome to use the name of the theorem. Again, remember, we don't want to be using the numbers. The name is fine, or you can give a brief description. Students in the past have preferred to use the name. And so if you see congruent supplements theorem, what we're saying is two angles supplementary to the same angle or to congruent angles are congruent. So the congruent supplements theorem says that angles that are supplements to the same angle are congruent angles. So angle 1 and angle 2 are supplements. Angle 2 and angle 3 are supplements. So because 1 and 3 are both supplementary to the same angle, 2, we can then conclude that angles 1 and angle 3 are congruent, that their measurements are the same. The congruent complements theorem states that two angles that are congruent to the same third angle are congruent. So if 4 and 5 are complementary and 5 and 6 are complementary, then we can say that 4 and 6 are congruent. So any two angles that are complementary to the same third angle are congruent. If the measurement of 4 plus the measurement of 5 equals 90 degrees, and the measurement of 6 plus the measurement of 5 equals 90 degrees, we can conclude that the measurement of 4 is equal to the measurement of 6. All right, so here's the one proof that we're going to utilize in this instructional video. So we're going to walk through it, pause, go back, go forward as much as you need to. In this figure, angle 1 and angle 4 form a linear pair, and the measurement of 3 plus the measurement of 1 is equal to 180. What we want to prove is that angle 3 and angle 4 are congruent. So we're going to start by stating our givens. So we are given that angle 1 and angle 4 form a linear pair. We are also given that the measurement of angle 1 plus the measurement of angle 3 is equal to 180 degrees. And our reason for this step is given. That's the information that we are given in there. Now, we want to prove that 3 and 4 are congruent. In order to prove that 3 and 4 are congruent, I probably need to prove that 1 and 2 are congruent. Or I need to prove that 1 and 3 are supplementary and 4 and 1 are supplementary. That would be another avenue that I could take. So looking at what I know, I see that 1 and 4 are supplementary, and the reason why I can say that they're supplementary is because all linear pairs are supplementary. So I think I'm going to do the supplementary route. I'm going to say that 1 and 4 are supplementary, and I know from this statement that 3 and 1 are supplementary because of the definition of supplementary angles. So then I can use the congruent supplements theorem. Okay, so I wrote down my given statement. I processed through how I'm going to get there. Now I'm going to write down what I know. That 1 and 4 are supplementary. So angle 1 and angle 4 are supplementary. And why are they supplementary? They are supplementary because all linear pairs are supplementary. I also know that 1 and 3 are supplementary because of the definition of supplementary angles. We know that supplementary angles have a combined measurement of 180 degrees. So I'm going to say that angle 1 and angle 3 are supplementary. And the reason why they're supplementary is because of the definition of supplementary angles. And so therefore I can say that angle 3 and angle 4 are congruent. And the reason why I can say that is because of the congruent supplements theorem. All right. Now again, we're going to go through a couple proofs in class because I think it's important that we have that dialogue in class, especially when we're trying to develop a proof. So 2 more slides of notes for you to have. When you come to class tomorrow, I really want you to have a good understanding of what those are. So let's look at the next one. We have the vertical angles theorem. 2 angles are vertical, then they are congruent. If 2 angles are vertical, then they are congruent. It will be helpful to have the name, the definition, a photo, and the example all included in your notes. It may seem like it's a lot to add in right now or maybe too much. I can tell you in a month or so when you have to come back and you're trying to figure out a reason to justify, that will be a good, helpful reminder for you to have it all in your notes. And the last page of notes that you have are all the right angle theorems. And these are all different theorems related to right angles. Perpendicular lines intersect to form 4 right angles. All right angles are congruent. Perpendicular lines form congruent adjacent angles. If 2 angles are congruent and supplementary, then each angle is a right angle. And if 2 congruent angles form a linear pair, then they are right angles. These are all different reasons that you can use within your proofs. And so throughout this lesson, you learned probably 12 new postulates, theorems, ideas. And when you come to class tomorrow, I want you to have a good grasp on those. So that means when you finish writing these down in the video, it doesn't mean we just put our notebook away and we worry about it tomorrow in class. I want you to spend a few minutes tonight looking through, practicing, reminding yourself. If you have a minute or two on the bus to peek, that would be good. Just become familiar with them. As we put together proofs, it's going to make you a more efficient proofwriter if you understand and know many different reasons that you can use. If you need to refer back to your notes continually because you're not sure, that's going to slow your process down and it might lead to some frustration. So please have a good understanding of what these are. So when I say what are the 5 right angle theorems, you're not like, oh, where are my notes? I got to check it out. Try to have at least 3 or 4 of them ready to go for tomorrow and practice them. Maybe have a parent quiz you. That would also be an option as well. I hope you have a wonderful night, and I look forward to seeing you in class.